Let's look closely at a Type K thermocouple. A Type K thermocouple is probably the most commonly used thermocouple in industrial applications because it responds predictably across a very wide range of temperatures, say around negative 330 degrees Fahrenheit to around positive 2,460 degrees Fahrenheit. The exact temperature ranges will change a bit based on how the manufacturer builds the body of the probe and the insulating materials used, but with that wide range, you can see why it can handle almost any application. Type K thermocouples are made from the metal alloys chromel and alumel. As we heat the wires, you'll notice that the electrons in the chromel wire don't move around as much as the electrons in the alumel wire. Over a very short period of time, you can see the alumel wire has more electrons collecting at the cold junction, the cooler end, which means the alumel wire will have a negative charge compared to the chromel wire. This difference in charge, also called the voltage, can be measured. The more heat you apply to the metal wires, the more the electrons want to move around, and the more they move away from the heat. With the two different types of metal wire, the difference in the voltage will increase and decrease with changes in heat at the sensing point. The thermocouple voltages are very small. The actual change in voltage per degree Celsius is minuscule. For example, for a Type K, the change is about 41 microvolts per degree Celsius. Also, interestingly, all thermocouple voltages are 0 millivolts at 0 degrees Celsius. Because the thermocouple manufacturers carefully select the metal alloys when they build the thermocouples, anyone can convert those voltages into temperatures using standard calculations. In fact, most manufacturers will provide some voltage to temperature charts so that you can get a good idea of the temperature difference between the hot and cold junctions.